Hey guys, in this video we're going to be looking at how to simplify single algebraic fractions. So we're going to build up to attacking things like this chap here, 4x squared minus 9 over 2x squared plus 5x plus 3. But before we get anywhere near that, we're going to build up to it. So first of all, some really useful skills that we're going to need for this technique. First of all, simplify numeric fractions. So for example, if I gave you 15 twentieths, factorising simple algebraic expressions. So if I gave you something like 2x squared add 8x and asked you to factorise that fully. And then finally, factorising simple quadratics. So if I gave you something like x squared plus 5x plus 6. Now pause the video and see how you get on with those three questions. Okay, so let's go over them. So 15 over 20 has a common factor here of 5. So if we divide top and bottom by 5, that would leave us with 3/4. Factorise 2x squared plus 8x. Well, the highest common factor there is 2x. So we would get 2x lots of x plus 4. And then factorising x squared, add 5x, add 6. Hopefully you got x, add 2, times x, add 3. If any of that gave you any trouble at all, check out the videos on them and come back. Okay, two more useful skills. Recognising the difference of two squares. So would you be able to factorise something like 4x squared minus 9? And factorising harder quadratics. So if I gave you 2x squared plus 5x plus 3, would you be able to factorise those two? So again, pause the video, have a go. And hopefully then you would have got 4x squared minus 9 is indeed an example of a difference of two squares. That would factorise to 2x plus 3 times 2x minus 3 like that. And hopefully then with this chap at the bottom you managed to factorise this guy to 2x add 3 times x plus 1 like that. So again, if any of this has given you any trouble, go back and check out the videos on each of them, then come back and play with this. Okay, so we're going to run through 8 examples, starting off incredibly simple and building up to the big boys. So if we want to simplify 4x over 8, this is almost the same as just simplifying a normal numeric fraction, except we've got that x up on top. So what's the highest common factor between 4 and 8? Well, it's 4, so we can divide the top and bottom by 4, and that will leave us with x over 2. Jobs are good, they get trickier. Okay, example 2. 9x add 6 over 6x add 4. So, what we need to do here then is check the top and bottom and see if we can factorise them. So is there anything that we can factor out of 9x add 6? Yes, there is. There's a common factor of 3. So if we factorise the top, we get 3 lots of 3x add 2. And then if we look on the bottom, is there a common factor between 6 and 4? Yes, there is. There's a factor of 2. So if we factorise the bottom, we get 2 lots of 3x add 2. Happy days. We've got a common factor on the top and bottom of 3x add 2. So this would just cancel down to 3 over 2. 3 halves. Jobs are good. Example 3. X squared minus 25 over x plus 5. So there's nothing on the bottom that we can do to the x plus 5, that's in its simplest form. But this chap up on the top is an example of a difference of two squares. So x squared minus 25 factorises to x plus 5 times x minus 5 like that. And now if we think of this x plus 5 as being inside of a bracket on the bottom, we're absolutely allowed to do that. Hello, we've got our common factor of x plus 5. So the answer here is x minus 5. Jobs are good 'un. Example 4. 2x squared add 4x over 10x squared minus 8x. So if we wanted to, we could do this step by step. We've got more than one common factor on the top and the bottom. So let's do it step by step, why not? So the top has got a common factor of 2. So we could write the top as 2 lots of x squared plus 2x. Now the bottom has also got a common factor of 2. So if we factorise the bottom, we get 2 lots of 5x squared minus 4x. So the top and bottom both have a common factor of 2. So that can disappear. And that will leave us with x squared add 2x all over 5x squared minus 4x. Now the top and bottom still have a common factor of x. So we could now factorise the top and bottom. The top would become x lots of x plus 2. And the bottom would become x lots of 5x minus 4. So again, those common factors of x cancel each other out and leave us with x add 2 over 5x minus 4. Nothing else we can do. Jobs are good 'un. Okay, example 5. So here we've got two quadratics, one on the top and one on the bottom. So we need to factorise each quadratic and hope that we get a common factor. So x squared plus 5x plus 6 factorises to x plus 2 times x plus 3. So there's the top factorised. And then x squared add 8x add 15 factorises to x plus 3 times x plus 5. Now, do we have a common factor top and bottom? Yes, we do. We've got the x plus 3's. So they cancel each other out and leave us with x plus 2 on the top over x plus 5 on the bottom. Jobs are good 'un again. Okay, example 6. X squared minus 100 over x squared minus 15x plus 50. So we've got a difference of 2 squares quadratic on the top and a nice normal quadratic on the bottom. So x squared minus 100 factorises to x plus 10 times x minus 10. Let's hope that we get one of those factors on the bottom. So x squared minus 15x at 50. That's going to factorise to x minus 10 times x minus 5. Ideal, we've got our common factor there of x minus 10, so they cancel each other out, and we get left with x plus 10 divided by x minus 5. Jobs are good 'un. Example 7. 4x squared minus 9 over 2x squared plus 5x plus 3. Okay, so here we do have a difference of 2 squares up on top, and we have a slightly trickier quadratic on the bottom. So if you're able to spot that you've got a difference of 2 squares on top, factorising that first of all gives us a clue as to how to factorise on the bottom. So 4x squared minus 9 factorises to 2x plus 3 times 2x minus 3. So that's the top factorised. Now, given that we've been asked to factorise and simplify this this fraction as much as possible, that means there has to be a common factor on the top and on the bottom. So that means down here, one of our brackets has to have a 2x in it. Now if that bracket's got a 2x in it, then to get the 2x squared, we need to have an x in the other bracket. Now for that to be a common factor, we have to either have then a positive 3 or a minus 3 in here with 2x. Now we know that 3 needs to multiply with the number in the other bracket to give us the 3 at the end there. So that means that's going to have to be a 1. Now, given that everything in that bottom quadratic is positive, that tells us both of these brackets here contain positive numbers. So now we've got our common factor on the top and bottom, 2x add 3's. So this bad boy simplifies to 2x minus 3 all over x plus 1. Jobs are good in. Okay, one more guys. Example 8. X cubed add 3x squared add 2x over x squared minus 4. So we've got something a bit new in this one on top. We've got a cubic. But that cubic does have a common factor of x. So let's just work on the top for a second. So we could factor out an x up on top, and that will leave us with x lots of x squared plus 3x plus 2. Now we've got a nice normal quadratic inside of that bracket, so we can factorise that further to x lots of x plus 1 times x plus 2. So that's the top fully factorised. Now on the bottom we've got x squared minus 4, which again is a difference of 2 squares, so he factorises to x plus 2 times x minus 2. So there's our fully factorised fraction. Now, do we have a common factor on the top and bottom? Yes, we do. We've got an x plus 2 on both. So this could simplify down to x lots of x plus 1 over x minus 2. Or we could even get away writing that as x squared plus x over x minus 2. Okay guys, that's how we simplify algebraic fractions. There's lots more fun to be had with them, where we'll be looking at questions involving 2 or more fractions, and we also solve equations with this sort of fraction in as well. Hope this has been useful. Was this video helpful? If so, be sure to leave a thumbs up and a comment telling me how you get on. For any further information, you can follow me on Facebook and Twitter, and send requests or any feedback you have. Search for Maths with Mouth. Cheers guys.